All right, today we're going to take care of two different parts of solving systems and equations. On Friday of last week, we worked with graphing, and graphing has a lot of drawbacks. You have to have graph paper, you have to have nice, easy answers, and things like that. So today we're going to work on the substitution method and the elimination method. So here we go. Okay, the substitution method. It is exactly as it says. If you look at this second equation here, it says y equals. So that means that every place in the first that I see y, I can put this and I can substitute that right in there. So when I use the substitution technique, I don't put 4x plus 2 in for y. So 4x plus 2, I just put it in there, plus 4 is equal to negative 2x. And that means that 4x plus 6 is equal to negative 2x. I don't subtract the 4x from both sides. 6 is equal to negative 6x. X is equal to negative 1. Now remember, when I solve a system, I'm looking for their intersection points. I have just found the x coordinate of that intersection point. And now I want to take this answer and put it into one of these two. It really doesn't make any difference which one. I usually put it into one I find easiest. Well, putting it into this one that I have circled looks to be the easiest for me. So this is y is equal to 4 times negative 1 plus 2. Y is equal to negative 4 plus 2, which is negative 2. So there's the intersection. All right, another nice easy one. So maybe we could have graphed this just as easily, but that's not necessarily always the point here, always the case. All right, so now when I substitute, the first step is I want to solve one of the two equations for either x or y. Actually, I'll even go further. I'd like for one of the two equations to be solved for either x or y. If it's not, then I'm going to use a different method, and I'll show you that other method here today too. Substitute that expression in for the variable that equals the other one, and that will have you solve that, and you'll get that particular answer. That's either an x or a y coordinate, and then you put that back into the original equation, one of those two, whichever is the easiest, and you find your answer. Let's give you a couple more examples of this. Now, on this particular equation, the system, the red one, 5x minus 3y equals negative 1, that's not very friendly. It's not solved for either x or y. I'm not going to mess with that. The bottom equation, though, is solved for y. So I'm going to put this right here in for this y. So it will be 5x minus 3 times negative x plus 3 is equal to negative 1. One of the habits I have is when I put this particular, whatever I substitute in for that variable, I have a tendency to put parentheses around it. It just shows me, hey, I put this in there. And now I'm going to distribute to get rid of that, the parentheses. So 5x plus 3x minus 9 is equal to negative 1. I don't combine and move the 9 at the same time. So I get 8x, I'm going to add 9 to both sides, is equal to 8, x is 1. All right, good. So I got 1. Now I'm going to pick and choose which one I want to put this in. Well, it makes a lot of sense to put it into the black one. So y is equal to the opposite. 1 plus 3. So y is equal to 2. Okay, another one done. Now, this particular equation, I got to tell you, honestly, when I see something like this, I probably don't use the substitution method. But since I'm being told that I have to, I'm going to pick on the one that I find easiest to mess with. I think the top equation right here is easiest to mess with, and I'm going to solve for x because all it takes is to move this 3y to the other side. So I'm going to do that down below. All right, so now I've just solved this equation for x. Now I'm going to put this x value right here in for that x. Okay. Now I do my do. I do the deal here. So 6y minus 10 minus 4y is equal to negative 5. 2y minus 10 is equal to negative 5. 2y is equal to 5. And that means that y is equal to 5 over 2. Okay, now this is one of the reasons why we choose to use this particular method. Graphing this, that'd be tough. You have to get exactly there, and you have to be exactly sure that that's 2.5. So, excuse me, let's do, now I go back to the beginning. I'm looking at one of these two, trying to decide which one I want to put this in for. Honestly, the bottom one, this one right here, I kind of like that. The top one is going to be all kinds of fractions. You can choose, but I kind of like this one because if you notice, negative 2 over 1 times 5 over 2 minus 4y is equal to negative 5. Those go away. Negative 5 minus 4y is equal to negative 5. Let's add the 5 to both sides. Y is 0. Now, it would have worked if I did the other way. It sure would have. I would not have had the two friendly numbers there. That's why I chose that one. Could I go on the other side? I sure could have, but I wouldn't have those friendly numbers, and that kind of changed me away from that. Again, neither of these is solved for x or y, so sometimes I'm not necessarily too happy about using this particular method when I don't have one that's solved for the x or the y. But since it was, I picked on the one I felt like was the easiest. Good. Back to the good one here. I know what y is. It's 5. Ooh, that means I know the y coordinate of my answer. So let's substitute this in for this y. Negative 2x minus 10 is equal to negative 6. Let's add 10 to both sides. Now you can always go back through and double check your answer. So if I would put this negative 2 in there for the x, minus 2 times 5 is equal to negative 6. Alright, so this is a negative 2, so that's 4 minus 10 is equal to negative 6. Well, that's true. Negative 6 is equal to negative 6. That's the right coordinate pair. Remember, what we're looking for is where do they cross. Now, what happens if I do all this math, I end up with 4 equals 4? No x, no nothing like that. Well, is 4 equal to 4? Sure is. That tells me that these are the same line. Now, the other way, if I end up with 5 is equal to 4, that's no. That means that these two lines are parallel, and there's no solution. Gotta watch out for this. Now, the next method that we have, I gotta tell you, I graph only when I have to. The substitution method, only when it's easy. The elimination method, any chance I can. So what we're trying to do is we're trying to eliminate the x or the y. I would generally say that you want to put this into standard form, meaning that I got all the letters on one side and the numbers on the other side. Then what I look for is I look to see how can I add these two equations away to get rid of one of the two variables. Now in this particular problem, this is set up great because I notice that the 6x's, one's positive, one's negative. So if I add those up, that goes away. So I end up with 9y is equal to negative 9. Y is negative 1. Okay, so I get negative 1 for my one answer. Now, pick one of these two. Again, whichever one you feel like is going to be easier. I'm going to go with the bottom one. I don't know why. Okay, and again, notice that when I substitute something in, I put in parentheses. So 6x minus 4 is equal to negative 10. 6x is equal to, move that over, negative 6. X is negative 1. Again, if you wanted to, you could substitute those numbers in there and find out what those answers are to make sure that they end up to be correct. But usually I just go to the next problem. Okay, what can you do to eliminate a variable? Add equation together, multiply by a particular number, multiply both equations by a number. Eliminate, solve, substitute, solve. This particular problem. Now, in looking at this one, it's not quite as easy as that first one that we did. And the reason is none of those numbers are the opposite side of each other. 5, 10, 1, -7. They don't work. So what I want to do is I want to multiply either the top or the bottom equation by a particular value that can get rid of it. Now, there's two values here that I can see that make sense to get rid of. I'm going to choose to multiply the top one by 7. Okay, now I multiply everything in that top by 7. So 7 times 3 is 35x. 7 times positive 1 is positive 7y. And 7 times 9 is 63. Now the reason I chose the 7 is because that way I didn't have to worry about any signs changing. I knew that I had these two signs the opposite. Could I multiply the top by -2? I sure could have, because if I do a -2, that's -10, and that will go away. That would work too. Doesn't matter. Now that I got these two things lined up, let's add them up. Ooh, 45x is equal to, that always makes me nervous, but you know what? I believe that's 45. So that means x is 1. Now, I know what x is. Let's go back to the originals. Pick on the one that you want to. I don't pick on the top one this time. Honestly, numbers are smaller. Equals 9. 5 plus y is equal to 9. Y is equal to 4. So there it is. Every single time I'm looking for that intersection point. Sometimes there won't be one because they could be parallel. Okay, and when they're parallel, there's no solution. 5 is equal to 5. 5 is equal to 10. If it's all real numbers, that means they're right on top of each other. 4 is equal to 4. Okay, now this particular problem. Hey, this particular problem, there is absolutely no way I'm doing this one by the substitution method. By the elimination method. I'd have to add the x over here. If I did this, I'd have to add the x and then go from there. Why not just substitute this in here? Okay, in this case, I would use the substitution method, not the elimination method. But directions say I have to, so I'm going to cross this out, and I'm going to go through and do this one that way. I don't try to, well, actually I need this. So that's what it is here. I want to get rid of which one? It doesn't make any difference. Let's just multiply by -2. What that does, it gets rid of everything. Okay, so when I do that, I get rid of everything here. So that means that 0 is equal to 0. Well, that's a true statement. This is all real numbers. These are the same line. All right, so if I go back here, if I looked at, here's what this one was, and after I move the x over there, I have this. If I multiply this one by 2, don't I get 2x plus 2y is equal to 4? And those two equations are exactly the same. So that's why I really like that. I gotta tell you, most times I gotta do the math first, and I don't think about doing this. So it really pays off to be able to do this. Here, holy cow. There isn't a quick and easy fix between those two. They're just ugly. They're not very nice to each other. So now I have to think about which one do I want to get rid of. And it doesn't really matter. You can pick on one or the other. If you always want to, you can always get rid of the x's, or you can always get rid of the y's. In this case, I like that the number that when I get rid of it is a 10. So I'm going to multiply this top one by 5 and this bottom one by -2. Now, why the -2? -2 times -5 is positive 10, and this is a -10. So that's why I chose that. So I believe I get 15x minus 10y is equal to 10. And this other one, I get negative 10x plus 10y is equal to negative 20. Now, if I add these up, this is a goner. So this is negative 10, and this is 5x. That means x is negative 2. All right, good. We got an intersection. Now pick. Where do you want to put this? Now, I believe in the, keep it simple. So I'm going to put it into the smallest one. So 3 times negative 2 minus 2y is equal to 2. Negative 6 minus 2y is equal to 2. Negative 2y is equal to 8. Y is equal to negative 4. Great practice for algebra or solving equation skills here. All right, that should be about it for today. So if you have any questions about as you work on these, please send me an email. Hopefully a little bit earlier today. Hopefully you're doing this early enough in the day that you can send me that. Even if you send it to me late at night, I'll probably respond to it the next day and give you a screencastify so that you can see what's going on and I can answer some questions that way. But please feel free to do that. The whole goal here is to get you guys better. So I really want to make sure that you guys have the opportunity to get better, and we go from there. All right, we'll talk to you guys. When do I see you guys? I think I see you guys on Thursday. Holy cow, it's gonna be a long time. Adios.